Hi students, in this class we shall be taking the most important questions for correlation and regression. This will be a video series of about 5 videos. Okay, it will be about 5 videos. We shall be completing about 70 to 80 questions, 10 questions or 20 questions per video. Okay, depending upon the length of the questions that come across. Okay, so we shall proceed with the questions. Let us consider the first question. The first question is as follows. Okay, so here the first question says that we need to find the correlation coefficient or coefficient of correlation R between x and y when the covariance of xy is given to you, the variance of x is given to you, and the variance of y is given to you. Okay, what is the correlation coefficient? So we need to find the coefficient of correlation. Okay, coefficient of correlation. So what is coefficient of correlation? Coefficient of correlation. Okay, it is denoted by R, right? And the formula as per given, okay, we have the covariance, we have the variance, so therefore I think we shall use this formula. The formula is, this is R is equal to covariance of x comma y, that is known to us, divided by standard deviation of x into standard deviation of y. Okay, so the variance of x is 2.89 and variance of y is known to us, so we shall take the square root of that. Okay, so what we have is sigma x the whole square equal to 2.89. okay, and sigma y the whole square is equal to 100. That is again simple. Now what we are going to do here is we shall take the sigma x into sigma y will be equal to, what is sigma x? Sigma x into sigma y. Sigma x into sigma y will be equal to the square root of the product of the variances, right? So that is sigma x square into sigma y square. So we shall take the product first of all. Take the product. So it is 2.89 into 100 and the root of that is equal to the square root of 289. Okay, which we shall use this item and then go further. Okay, what is 289 the square root? So therefore what is covariance of xy? Covariance of xy is minus 16.5. so this is minus 16.5 divided by sigma x into sigma y we have calculated as root of 289. Okay, so what is this? This is square root of 289. So what we have here is equal to, so this is 17, right? So minus 16.5 divided by 17, and when we calculate this thing using the calculator, what we get is minus 0.97. so just look into the options, which one is the correct option? Option A, minus 0.97 is our correct answer. This is option A is the correct answer. Okay, next question. Let us look at the next question. Now let us look at the second question. The second question what we have is take 200 and 150 respectively as the assumed mean for x and y series of 11 values. Okay, here what we have is n is equal to 11, okay, so this is n. Okay, n is equal to 11, and then we have dx as x minus, okay, assumed mean is 200, so from every value of x we are subtracting 200, and from every value of y we subtract 150, so we get the reduced values or the deviations. Okay, that is dx and dy respectively, whatever it may be. Okay, so then, and the sum of all dx would be 13, and sum of dx square of the deviation, sum of square of deviations is given to you, and then sum of dy is given to you, and sum of the squares of deviations of y is also given to you, and the product of deviations, sum of product of deviations is also known to you. So all these things are known to you. We need to calculate the value of r. We directly know the formula. To find out the coefficient of correlation r, the direct method as this. Okay, so instead of xi and yi we will be using dx and dy. So for every x we replace the x by dx, and we replace yi by dy. So the formula becomes n into sigma dx dy minus sigma dx into sigma dy. divided by n into sigma dx square minus sigma dx the whole square. Here n into sigma dy square minus sigma dy whole square. Okay, so that's it. So we shall use this formula, but instead of x we will say dx. Okay, so rxy, let us consider this formula. So rxy becomes r of xy will become equal to, what is that, n is equal to 11 in this case, so we will put 11 into sigma dx into dy. Okay, sigma dx into dy. Where is sigma dx into dy? Sigma dx into dy is 3943. Okay, so it is 3943. Okay, minus. So we have the minus sign. Then sigma x. Where is the sigma dx? Instead of sigma x, we will be taking sigma dx. That is 13 into sigma dy. Sigma dy is 42. So we have 42 here. Okay, divided by the square root of n into the square root of n. N is equal to 11 into what is sigma xi square. Sigma xi square is, that is, instead of xi we will be taking dxi square. That is 2667. Okay, into 2667. So this is one part, minus the square of sigma xi. Square of sigma xi. What is sigma xi? Sigma xi is 13. Okay, so it is 13 square. Okay, same way, into the square root of 11 into sigma yi square. So that is sigma dy square, that is 6964, and 11 into 6964 minus sigma dy square. Okay, sigma dy square. Where is sigma dy square? Or sigma dy whole square. Where is sigma dy? Sigma dy is 42. So 42 square. Okay, so what we have here is, so we can simplify this thing. We can simplify and calculate using the calculator. You know how to calculate. And finally, what we get here is 0.92. Okay, so our answer would be C, option C, 0.92. So I'm just making you familiar to what kind of questions can come and how we need to attempt that question and which formula to use. Okay, so that is how we can do it as fast as possible. Into this formula, just put the values. So this is given and this is given. Okay, coefficient of correlation is not affected by change in. So if you subtract every observation, from every observation something, then the result will not get affected. Okay, next question is question number 3. So for some bivariate data, the following results were obtained for the two variables x and y. So we have x bar, we have y bar, we have byx. Okay, this is regression coefficient. Okay, this is a regression type of problem. So here we have the mean of x, mean of y, the regression coefficient of y on x and regression coefficient of x on y. And we are supposed to find out the most probable value of y when x equal to 60. So that is, we need to find out the regression equation of y on x, because y depends on x, value of x is given to you. Okay, so we need to go for the regression equation of y on x. Okay, a regression equation of y on x. What is that, or how is it given? It is given as y minus y bar equal to b of yx. Okay, b of yx into x minus x bar. Okay, this will give you the equation, and into the equation we need to put the value of x, and you get the value of y. Okay, so what we have here is y minus, what is y bar? Y bar is 27.9. Okay, 27.9. It is 27.9. Okay, equal to, this is byx. What is byx? It is minus 1.5 into x minus, what is x bar? X bar is 53.2. Okay, this is 53.2. So y minus something equal to something. Okay, so how to solve this? We need to multiply this minus 1.5 to x as well as this number. So simplifying, we get y will be y minus 27.9 equal to minus 1.5x, then plus 53.2 into 1.5. Let me calculate. It is 1.5 into 53.2. What you get is 79.8. Okay, so what we get here is 79.8. Okay, so we shall have y equal to something form. Okay, so y will be equal to minus 1.5 into x, then this will go that side. Okay, so and get added with 79.8. So 79.8 plus 27.9. Okay, plus 27.9, what you get is 107.7. Okay, so we get will be equal to plus 107.7. Okay, this is the regression equation of y on x. In this equation, we need to put the value of x as 60. So y for x equal to 60, what do we get? What is the value of y? That is what we need to find. Okay, so this is minus 1.5 x. Instead of x, we'll put 60 plus 107.7. Okay, so calculating what is 15 into 6. 15 into 6 is 90. Okay, so it is 9 minus 9 plus 107.5. Okay, so what we have here is minus 90 into 107.5. Okay, so this is minus 90 plus 107.7, which will give you the result is 17.7. The result is 17.7. What is this? This is y. For x equal to 60, y is equal to 17.7. What is the answer? Option D. Option D, 17.7 is your answer. Okay, now let us move on to the next question, question number 4. In question number 4, what is given to us? Let us try to understand. If the sum of squares of the rank difference, sum of squares of difference of ranks in mathematics and physics is given to you, okay, for 10 students, and that is 22. Okay, then that is sigma di. Sigma di is given to you. What is given to you? Sigma di is given to you. Sigma di, or a sum of difference of ranks. So it is rank correlation coefficient type of question. Okay, so sigma di square is given to you as 22, and we have n is equal to 10. Okay, so the sum of squares of the difference of rank, it is denoted by sigma di square. Sigma di square is 22 and n is equal to 10. So how to find the rank correlation coefficient? So it is very simple. We know the formula. The formula is RR, or rank correlation coefficient. This is the rank correlation coefficient. Okay, RR will be equal to 1 minus 6 into sigma di square divided by n into n square minus 1. We all know this formula. We just need to put the values. 1 minus 6 into sigma di square is 22. So 22 divided by n. N is equal to 10. 10 into, this is 10 square minus 1, which is equal to, again we can simplify as say 1 minus 26 into 22. What do we get? 6 into 22 divided by 10. 6 into 22 divided by 10 into 99. So we can simplify this by 11 2s are 22 and 11 9s are 99. So this becomes equal to 1 minus say this is 6 into 2 divided by 10 into 9. We can further simplify 3. I use a different color. So this can be cut as 3 2s are 6, 3 3s are 9. Okay. So therefore, and then further, if you want, 2 1s are 2 5s are. So the result will be equal to, 1 minus 2 1s are 2 divided by 5 3s are 15. So finally it is 15 minus 2 divided by 15. What is 15 minus 2? 15 minus 2 is 13. 13 by 15. So just calculate 13 by 15. What are you getting? It will be equal to 0.867. Approximate value will be 0.867. So option B 0.867 will be your answer. So rank correlation coefficient, the formula is this. See, the formula should strike to you at the earliest. What kind of formula and which values are given to you. Read the question properly once or if possible twice, and then decide upon what formula to apply. Okay, that will be applicable for each and every question. There may be different variations of the same formula, but according to the given, you should choose the most appropriate formula so that your calculations may be faster. Okay, next question, question number 5. In question number 5, two random variables have the regression lines as given. Okay, so what is given to you? They have the regression lines as 3x plus 2y equal to 26 and 6y plus y equal to 31. Okay, so then we need to find out the coefficient of correlation between x and y. So how to find out? We need to find out R. Okay, coefficient of correlation. It is not regression. So here we have the regression lines. Say first one, we don't know which one is x on y and which one is y on x. So let me assume that the first one. Okay, let us assume that 3x plus 2y equal to 26 is for y on x. Okay, so then we can have the regression coefficient from this. Okay, and how to do that? This is y will be equal to this 3x will go that side, so it becomes a minus 3x plus 26, and this coefficient of y, which was 2, will be divided. This is 2, this is 2. Okay, so we have this as the regression coefficient of y on x. This is b y on x. Okay, we have this value. Now from the next equation, what we have here is 6x plus y equal to 31. Let 6x plus y equal to 31 be the regression equation of x on y. So when it is x on y, we isolate x. Okay, so what we do here is x will be equal to minus y plus 31. So here 6 was the coefficient of x, so we need to divide. So this is 1 by 6 minus 1 by 6 and 31 by 6. So here what we have, this item, the coefficient of y, this is b of xy. Okay, the correlation coefficient of x on y. Is that okay? Now we know that the correlation coefficient r, okay, r is equal to r, or the square of r will be equal to bxy into byx. Okay, we know this formula. The square of the regression coefficient will be equal to bxy into byx. The product of the regression coefficients will give you the correlation, the square of the correlation coefficient. So what is bxy? Bxy is equal to minus 1 by 6. So it is minus 1 by 6 into byx. Byx was minus 3 by 2. It is minus 3 by 2. So we can multiply or calculate this thing. So minus minus is plus. So this is 3 by 6 2 is 12, or 3. We can cancel this, right? When we multiply, so this is 3 1s are 3, 3 2s are 6. So you get minus minus plus 1 by 4. Okay, what we get here is 1 by 4, or we can say it is 0.14. Both the regression coefficients are negative. Okay, so r square is equal to 1 by 4. R square is equal to 1 by 4. But what you need to be careful here is, see, you need to be very careful. The sign of the regression coefficient, both the sign of the regression coefficients are negative, right? Signs of both the regression coefficients are negative, therefore the correlation coefficient will also be negative. Okay, so r will be equal to, so we can have, this implies that r is equal to plus or minus 1 by 2, right? R is equal to plus or minus 1 by 2. So we have r is equal to plus or minus 1 by 2. Okay, so r is equal to plus or minus 1 by 2. So here we need to be careful that since the regression coefficients, both the regression coefficients are negative, the correlation coefficient r will also be negative, minus 1 by 2. Let us check the answer. Okay, this 1 by 2 will be equal to minus 0.5. Okay, So R is equal to minus 0.5. Option C is your answer. Option C is our answer. So that's it. What we need to prove or we need to find is correlation coefficient between X and Y. Okay, we have found that. Next question, question number 6. What is the question number 6? Coefficient of correlation between X and Y is given to you. Okay, coefficient of correlation R of XY is given to you as 0.6. Now, after change in scale and origin, we get U and V as x minus 3 by 2 and V is equal to y minus 3 by 2. And the coefficient of correlation between U and V is to be found out. Okay, R of UV is to be found out. Now we know that the correlation coefficient is not affected by the change in scale as well as origin, but it is affected by the sign of the scale factors. It is affected by sign of scale factors. Okay, if both the scale factors, here the scale factor means something which is multiplied or divided by which, so this 2 and this 3 are the scale factors. So both the scale factors are positive, are having the same sign. So therefore the correlation coefficient will not be changing. In case if it is different, if both of them have different signs, then the sign of RUV will change. Okay, so what we have here is, so R of UV will be equal to 0. Will be equal to R of XY, or it will be equal to minus R of XY. It will be equal to R of XY if the sign of the scale factors are equal, that is both positive or both negative, and it will be equal to minus of RXY if both of them are having different signs. In this case, we have both of them as having the same sign. Okay, they both of them have the same sign, so therefore it will be equal to the same and no change will happen. Okay, so option A 0.6 is the answer. Okay, here I think there should be a minus sign involved, which was not involved, so I shall take this and put minus here. Okay, so it is option C is minus 0.6. So we have corrected the options also. So R of XY is equal to 0.6, option A. The next question, question number 7. In question number 7, what are we supposed to find? For the following data, the coefficient of rank correlation has to be found out, right? So the rank in botany was given to you as 1, 2, 3, 4 and 5. The rank in chemistry is given as 2, 3, 1, 5 and 4. Okay, so we know all these things. We need to find out the coefficient of rank correlation. Coefficient of rank correlation, the formula is RR is equal to 1 minus 6 into sigma di square divided by n into n square minus 1. And for that purpose, we need the square of the deviations. Okay, so first of all, we are already given in ranks. Okay, the values are given in ranks only. Rank in biology, rank in botany and rank in chemistry. So here we need not convert them into ranks. They are already provided as ranks. Okay, now we need to find the differences in the ranks. Okay, so that is D is equal to Xi minus Yi. Okay, D or Di will be equal to Xi minus Yi. So here also sigma di square. So what will happen here? 1 minus 2 is minus 1, 2 minus 3 is equal to minus 1, 3 minus 1 equal to 2, 4 minus 5 equal to minus 1, 5 minus 4 equal to 1. Okay, so finally when we add all of this is a cross check. Okay, you remember my previous concept videos where we discussed the concept practice problems, and in that we have discussed that we always check that whether the sum of deviations, sum of differences in the ranks is equal to 0 or not. Okay, sigma di is always equal to 0. Now what we do is prepare the last column where we get the sum of the di's. Okay, so for that purpose we must take the square of these values. Di in the square of minus 1 is 1, square of 2 is 4, square of minus 1 is 1, square of 1 is 1. Sum of all di's will give you 8. This is sigma di square. So we put these values into the formula. When we put the values into the formula, what do we get? When we put the values into the formula, what we get here is 1 minus 6 into sigma di square is 8 divided by n. What is n? N is 1, 2, 3, 4 and 5. Okay, so it is 5 into, this is 5 square minus 1. So what we get here is 1 minus 6 into 8 divided by 5 into, this is 25 minus 1 is 24. 8 3s are, or 6 4s are 24. 6 into 4 is 24. 4 2s are 8. So this will be equal to 1 minus 2 by 5. 1 minus 2 by 5. What is 1 minus 2 by 5? 1 minus 2 by 5 will give you, this is 5 minus 2 divided by 5, which is equal to 5 minus 2 is 3 by 5, which is equal to, what is the value? This is equal to 0.6, approximately 0.6 or equal to 0.6. So let us check the answer. Option C, 0.6 is your correct answer. Next, question number 8. Question number 8, what is given to you? So this is a very important and complicated question. Just need to be careful. Okay. For the whatever is given, let us check out. Okay, for the following data based on 450 students. Okay, so what we have here is n is equal to 450, n is equal to 450, n is equal to 450. Okay, mean marks in statistics, mean marks in economics. Okay, we shall take this as x bar, we shall take this as x bar. Okay, x bar is equal to 40, and the same way for economics we shall take it as y bar. Okay, so what we have here is x bar is equal to 40 and y bar is equal to 48. Okay, so then standard deviation of statistics. Statistics was taken as x. Okay, so standard statistics will be taken as x and the economics will be taken as y. Okay, so here what we have is standard deviation sigma x. Sigma x is equal to 12. And what is sigma y? Sigma y will be, okay, here we have the variance. Okay, sigma y square, this is sigma x, this is sigma y square, which is variance. We need standard deviation. So it is, what is the square root of 256? The square root of 256 is known to us and it is equal to 16. So we shall take it as 16. Okay, so we have all the values. Now, what else is given to you? Sum of product of deviations. Sum of product of deviations of the marks from the respective means is given to you. Sum of product of deviations from the respective means is given to you. So, what we have here is sigma sum of product of deviations. So, dx into dy. Product of deviations from the respective means is given to you as 42075. Okay, so what is dx? Dx is equal to each xi minus x bar. Okay, so that is the differences from their respective means and then their sum. Okay, same way this is dy will be equal to yi minus y bar. Okay, and once you find all these things and then you take the product and then the sum. Okay, sum of the product. So that is given to you. Now we need to find out the average marks. Okay, we need to find out the average marks in economics. Economics means we need to find out y. Average marks of economics of the candidates who obtained 50 marks in statistics. Okay, so y equal to question mark when x equal to 50. Okay, y equal to question. What would be the marks of economics when the marks of statistics will be 50? Okay, so this is a kind of regression problem. This is a kind of problem of regression analysis. So we need to find y on x. Okay, equation of y on x. We are focused on y on x type regression. So for this, what we need is to find out the regression coefficient first of all. Sorry, the correlation coefficient r of xy. Okay, we need to find out rxy first of all. Rxy. What is rxy or r? Okay, that is equal to, what is the formula to find rxy? It is equal to covariance. It is covariance of x comma y, covariance of xy divided by sigma x into sigma y. Okay, so covariance of xy is defined as sigma dx into dy. Okay, sigma dx into dy divided by n. So into sigma x into sigma y. Okay, so this will be the formula to find correlation coefficient. So what is sigma dx into sigma dy? Sigma dx into dy will be equal to 42075. It is 42075 divided by n. N is equal to 450. So 450 into sigma x. Sigma x is 12 and sigma y is 16. Okay, we have 16 here, sorry, into 16. When we calculate this, we get 0.49. Okay, approximately 0.49. 49. This is the correlation coefficient. Now what we have is we need to find out the regression line. Okay, regression line of y on x. Okay, regression line of y on x. So regression line of y on x. It is given by, it is very clearly given by y minus y bar equal to b, y minus y bar equal to b of y on x. Okay, b of y on x into x minus x bar. Okay, so this is, see, what is byx? Byx can be written here. Okay, b of y over x can be written as r into sigma y by sigma x. This is what we need to know here. Y over x, so y is over x, sigma y divided by sigma x. We know this formula, so this can be used in this place. Okay, so this becomes y minus y bar. What is y bar? Y bar is 48. Okay, y bar is 48, so it is 48 equal to what is byx? Byx will be equal to r into sigma y by sigma x. So what is r? R is equal to 0.49. It is 0.49 into then 0.49 into sigma y. Sigma y is equal to 16 divided by 12 into 16 divided by 12 into x minus x bar. What is x? X, then we have x bar. X bar is 12. Okay, sorry, 40. It is 40. Okay, so what we can do here is simplify this thing. So this is y minus 48, and this can be further simplified, and it can be simplified as approximately it may be equal to 0.65. Okay, it can be taken as approximately as 0.65 into x minus 40. Okay, so this will be further simplified, and once you simplify, you know how to multiply 0.65 here and then with 40, and then take everything as and write it in the form of y equal to something form, y equal to ax plus b form or a plus bx form. Okay, so we shall write this as y equal to 0.65 into x plus 0.65 into x plus 22. Now what we have is we are supposed to find out y when x equal to 50. Okay, find y when x equal to 50. Find the marks of economics for candidates who obtained 50 marks in statistics. Okay, so y will be equal to, so y equal to question mark when x is equal to 50. So we shall put this into this equation. So what we have here is y equal to 0.65 into 50. So this is what we need to put. Okay, y is the question mark part, a plus 22. So this can be calculated further. 0.65 into 50. Okay, so 0.65 into 50 is 32. This is 32.5 plus 22. Okay, this will be equal to plus 22, which will be equal to 54. It will be 54.5 as your answer. So y is equal to 54.5. Let me see, check the answer. Okay, yes, option B 54.5 will be your answer. Okay, so in the doubt solving sessions we had taken this problem and done in a different way, and we stopped it midway due to some issues. I had to verify the question. It was a similar question or same question, I suppose. Okay, so this is the corrected version. Now we shall go on to the next question. Next question is question number 9. Okay, so here for 10 pairs of observation, so number of pairs is equal to n. Okay, so for 10 pairs of observation, number of concurrent deviations was found to be 4. What is the value of coefficient of concurrent deviation? We know the coefficient of concurrent deviation RC is given as plus minus root of plus minus 2c minus m divided by m. The plus, if it is both will be plus if 2c minus m is positive, and both will be taken as negative if 2c minus m is negative. Okay, we know all these things. We have discussed that in the theory classes. Okay, so here n is equal to number of xy pairs. What was the number of pairs? 10. Okay, so n is equal to 10. Okay, we have n equal to 10, And then what is C is the number of concurrent deviations. Number of concurrent deviations was found to be 4. So C is equal to 4. Okay. And then what is the value of the coefficient of concurrent deviations? We need to find out RC, coefficient of concurrent deviation. So we shall take this as plus minus root of, again plus minus, this is 2C minus M. Okay, what is M? M will be the total number of deviations. Total number of deviations will be n minus 1. So that is 9. Okay, so 2C, that is 2 into 4, that is 2 into 4, 2 into 4 minus 9 divided by 9. Okay, so this can be further calculated. When I calculate this thing, this is 4 2s are 8, so it is plus minus of this is 8 minus 9 divided by 9, and then the square root of that, and then again plus minus. So this part will be negative, so we'll take negative in both the inside as well as outside. So 8 minus 9 is 1, so it is 1 by 9. Okay, so minus minus will become plus. So it is minus root of 1 by 9. So it is equal to minus of 1 by 3. Okay. So minus 1 by 3 will be your coefficient of concurrent deviations. Next question, and the last question, question number 10 for this video. The covariance between the two variables is 20. Here the covariance between the two variables is 20, and the variance of one of the variables is known to you. Okay, the covariance of two variables, what we know here is covariance of x comma y is equal to 20. Okay, and let me take the variance of one of the variables as 16. So let me take sigma x is equal to 16. Let first variable sigma x equal to 16, and we need to find out the variance sigma x square is equal to 16. Okay, and sigma x y square, we need to find the variance of the other variable. Okay, we need to find the variance of the other variable. Okay, so what is sigma x? Sigma x will be equal to 4, and sigma y can be found out. So how to find out the covariance of xy? Covariance of xy, we know the formula that it is equal to, how to find the covariance of two variables? We know that, right? Sigma r will be equal to covariance of x comma y divided by sigma x into sigma y. Okay, we know this value. So this will be equal to, what is covariance of xy? It is given as 20 divided by what is sigma x? Sigma x is 4. So 4 into sigma y. Okay, so r is equal to 20 by 4 into sigma y. That is equal to, this is 4 5s, so it is 5 by sigma y. Okay, so now we know that the value of r lies between -1 and 1. Okay, it is -1 and 1. Okay, so what is r? R is equal to 5 by sigma y. Okay, r is equal to 5 by sigma y. Okay, please be careful here. Okay, so first thing is we will be multiplying by sigma y, or we shall multiply this thing by 1 by 5. What can we do? We will first of all take we shall take the reciprocals. So this becomes -1, reciprocal of -1 is -1, and this becomes sigma y, this becomes sigma y divided by 5, and this remains 1. But what happens when we take the reciprocal is the inequality gets reversed. Okay, inequality gets reversed like this. First it was less than, now it becomes greater than, right? Okay, so therefore now multiply by 5. What we have is -5 greater than or equal to sigma y greater than or equal to 5. Multiply by 5 throughout. So what happens here is, what we observe here is, you look here, this is -5 and this is 5. Okay, so sigma y is less than or equal to -5. Look here, sigma y is less than or equal to -5. So it will lie here. Or sigma y is greater than 5. It lies here. Okay, sigma y is less than -5 or sigma y is greater than -5. In both cases, the square will be greater than 25. Okay, sigma y square. Okay, sigma y square in both cases will be greater than 25. Square of 5 is 25. Square of minus 5 is also 25. So any value which is less than minus 5 will also give a square which is greater than 25, and any value which is greater than 5 will also give a square of greater than 25. So it will be greater than or equal to 25. Okay, so the minimum variance will be 25. So look at the question. Again here, more than 10, no, because we can have say 8 9, sorry, not 8 9, we can have 11, but 11 cannot be the variance. So the most appropriate answer here will be more than 100. Neither this nor this. Less than 10 is not possible. So variance is greater than or equal to 25. More than 1.25 is also not possible, because there are some values. There are some values in after 1.25. There are some, not some, but many values which are less than 25. Okay. So this is also not the correct answer. This is not the correct answer. This is not the correct answer. So this question was also discussed in the doubt sessions where we had a query. So please look into this question seriously. Okay. So thank you. That's all for this video. We shall meet in the next video as the part 2 of our important questions series. Thank you.